Here's a problem I really like, because it gives me a chance to exercise some drawing skills. It says, this is a Bernoulli problem, it says, lift is produced when air flows faster across the top of a wing than the bottom. So as a picture, we need to have a wing. So let's get a wing into this picture. And here's what a wing looks like in cross-section. How's that for a wing? Not bad. So here's what happens. Oh, there's probably more to it than a wing, isn't there? There's probably an airplane. So then the wing goes in like this, and then the rest of the airplane goes like this. So there's a wing, here's a wing on the other side, and so forth. Okay, right, might as well do the whole drawing while you're at it. It says this aircraft has air flowing across the top at 100 meters per second. So then across the top, here's air flowing, and the V across the top is 100 meters per second. And it says then across the bottom, it says the air is flowing at 80 meters per second. V bottom is 80 meters per second. Great. So that difference in the airspeed then is what generates the lift. Okay, right. There are a few more things that it tells us. It says the wing area is 60 square meters. So the area of the wing is 60 square meters. And it says that the density of air is 1.3 kilograms per cubic meter. Okay. Yeah, you can see that. It's right up there, isn't it? Funny, I can't see it. Okay. So then, oh boy, it wants to know the amount of lift force generated. So we need the force, lift force. So how do we get that? We need physics principles, and the physics principle here is the Bernoulli equation. And the Bernoulli equation says that the pressure any place plus 1/2 rho v squared at the same place plus rho g h at the same place is a constant. And so then that's the same as the corresponding quantity at some other place. P2 plus 1/2 rho v2 squared plus rho g h2. Okay, so that's the Bernoulli equation. Right. Does that look a lot like energy somehow? Because 1/2 mv squared is kinetic energy, mgh is potential energy, and this is some kind of energy, the pressure. It looks sort of like energy, it's related. Okay, good. So what we're after, oh, there's something else. Pressure, after all, is the force per unit area. And what we're really after is the force. And the force is a net force because there's pressure on the bottom, there's pressure on the top. So now what we really want is we want the pressure on the bottom minus the pressure on the top. So then if we call the top 1 and we call the bottom 2, then here's what we want. We want P2 minus P1. Bad looking P, my gosh. Okay. So how do we get that? Well, we have to work with the Bernoulli equation. A lot of terms in there, right? Yeah, but there is a little simplification because H1 and H2, that's the height above some reference level. And if we use the approximation of saying that this is a thin wing, then the thin wing means that H1 is about the same as H2. So we're just going to ignore those two terms. So we can say P2 minus P1, then put things on the other side, P2 minus V1. This is 1/2 rho V1 squared minus 1/2 rho V2 squared. Okay. We're getting someplace because now we have the differences in P. So then, okay, let's do a little factoring here. This is 1/2 rho times V1 squared minus V2 squared. And this is P2 minus P1. Okay, that's the delta P. So then the delta P is the force per unit area. So that's the lift force per unit area, like so. And if we're after the lift, then we can finally get at this and say the lift is the area multiplied by 1/2 rho V1 squared minus 1/2, minus V2 squared, sorry, that's already in there. 1/2 rho times V1 squared minus V2 squared, like that. A couple of parentheses there for all of you mathematics buffs. Great, so we know A, that's a known. We know rho, that's known. We know V1, we know V2. So from here on, it's nothing other than put in the numbers and find out what that finally is when we're all done. This is 1.4 times 10 to the 5th newtons. Seems like a lot of force, 1.4 times 10 to the 5th newtons. Right, this is an airplane after all. In order to keep the airplane up, you need plenty of force. And as we know from our experience, the airplanes seem to fly pretty well. Okay, so there it is, lift.